Hello students, I hope you are good, well and fine. Let's begin our topic, or shall I say, let's continue our topic on discussion on polynomials. Previously we discussed some algebraic identities, and let me recall you the algebraic identity we discussed, and then let's try to do some examples on based on that identities. Okay. So first, a plus b whole square is equals to a square plus 2ab plus b square. Second is a minus b whole square is equals to a square minus 2ab plus b square. Third is a square minus b square is equals to a plus b, a minus b. Fourth is a cube plus b cube is equals to a plus b whole, a product with a square minus ab plus a b square. Now let's move a cube minus b cube is equals to a minus b, product with a square plus ab plus b square. Sixth with a plus b whole cube is equals to a cube b cube plus 3ab a plus b, and then a minus b whole cube is equals to a cube minus b cube minus 3ab a minus b. Now the eighth one is a power 4 plus a square b square plus b power 4 is equals to a square plus ab plus b square, product with a square minus ab plus b square. I hope. And the last property is a cube plus b cube plus c cube minus 3ab is equals to a plus b times a square b square c square, sum of a square b square c square minus ab minus bc minus ac. And the special case for this property, if a b c sum is equals to 0, then what will be our resultant then? So this term will become 0, then this whole right hand side term become 0, then we only left with the left hand side, which is the sum of the cubes of abc minus 3abc is equals to 0. Then a cube plus b cube plus c cube is equals to 3abc. Okay, I hope you memorized all of the properties, and let's do now let's move further and see other forms, that if I have given a plus b and ab, or the sum of two numbers and the product of two numbers are given, then I will use the property a square plus b square, which is equals to a plus b whole square minus 2ab. You all just previously saw that a plus b whole square is equals to a square plus b squared plus 2ab. Then if the sum is given and the product is given, then we will be using this a plus b whole square minus 2ab. I just took this right hand term to the left hand side, then sign gets changed. Here is plus, then after getting to left hand side it will become minus. So if the sum and the product is given, then I will use this such a type of terms or the identity. If a minus b and ab are given and I have to find out a square plus a b square, then I will use this a minus b whole square plus 2ab. Okay. Now third, if a minus b and ab are given, I can also use this property also, a plus b is equals to a minus b whole square plus 4ab. So this means if squaring both sides, you will get a plus b whole square is equals to, and opening this square, which will give me a square plus b square minus 2ab plus 4ab, then 2ab 4ab, the 4ab, this means 4ab minus 2ab will give me what? 2ab. So I will just write plus 2ab, and I know this is what? This is a plus b whole square. So left hand side and the right hand side is equal. It is, we are just writing an identity in different forms so that we can take advantages of such as if the difference is given and the product is given, then I can either use this form to find out a plus b or use this form to find out the a square plus b square. Similarly, a minus b, we can find out if the sum and the product is given to me by using this property. Okay, you just solve, open this and write it in simplified form, then you will get automatically a minus b. So just don't get into the proof, just memorize them, and we will see that how we are going to use them. Okay, let's move. Here are some more. So as we all know, if a square plus b square, what we wrote in previous slide, for example here, the sum of whole square minus 2ab. So for here it is also, so a square plus 1 upon a square, or a square b square is a plus b whole square minus 2ab. If a is my just a square and b is my 1 upon a square, then a square plus 1 upon a square is not, say a square is a and b is my 1 upon a, then using a, let me write it again so that you don't get confused. Let me use different variables, different. Okay, so a plus b whole square minus 2ab, we all know what it equals to. It equals to a square plus b square. Okay, just I am taking small a as capital A and small b as capital B. Okay, so a, b and a, b. Okay, now what? Now let a is equals to small a and b is equals to 1 upon a. I hope this is now clear. So I am taking a is equals to small a and b is equals to 1 upon a. Then putting these value in my identity, what I will get? I will get a plus 1 upon a whole square minus 2 times a times 1 upon a is equals to a square plus 1 upon whole square. So this will get cancelled and it only remains here is 2. So now if you see, so this is my this fifth identity. I hope this is clear. So in the similar manner we can see that a square plus 1 upon a square is equals to a minus 1 upon a whole square plus 2. So give your attention, we will use these fifth and sixth when a plus 1 upon a is given and a minus 1 upon a is given respectively. And what if a plus b and ab are given and we have to find out the a cube plus b cube, then we will use a plus b whole cube minus 3ab product with a plus b. In similar manner, if a minus b, ab are given, then to find out a cube minus b cube, we use is equals to a minus b whole cube plus 3ab product with a minus b. So we just use the a minus b value and the product value to get a cube minus b cube. I hope these all are clear. Let's move further. Now more properties. So if you see, if a cube, so this must be a cube plus 1 upon a cube. What if we are given a plus 1 upon a and we have to find out a cube plus 1 upon a cube? Then we will use the ninth property, which says a cube plus 1 upon a cube is equals to a plus 1 upon a whole cube minus 3 times a plus 1 upon a. Okay, in the similar manner, we will be using 10th identity if a minus 1 upon a is given, and we are asked to find out a cube minus 1 upon a cube. So we will be using a minus 1 upon a whole cube plus 3 times a minus 1 upon a. Okay, I hope this is clear to you. So this is just 1 up a minus 1 upon a. Okay, okay. Now what? Now if you see that let's see. So for 11th property, you see 11th property, you see 12th, and you see the 13th property. These properties we will be using, but not so frequently. So I am just not going into just verbally say at loud at you. So just give your attention to these formulas also, or the identity. So now just we simply jump to our exercises or examples to understand the identities and how we are going to use those identities. Let's us see through an example. So first example says the find the value of 36x square plus 49y square plus 84xy when x is equals to 3 and y is equals to 6. So in order to find it, you can just simply solve for by putting the respective values. For example, 36 times x square, this means 3 square, plus 49 times y square, this means 6 square, plus 84 times x, which is 3, times y, which is 6. Now just evaluate it and you will get your answer. But this is a very lengthy process, so we will be using identities. Okay, so how we are going to use identities? If you are paying attention to it, so 36 is my 6 square, 49 is my 7 square, and 84 is just 2 times 6 times 7. What it equals to? It is 6 7 42, and 42 times 2 is 84. Yes, so now what we will do? So it is quite easy to see that I can write this 36x square as 6x square plus 7y whole square plus 2 times 6x times 7y. So this means if you see a plus b whole square, what it equals to? It equals to a square plus b square plus 2ab. So this is my identity which will be applying here. So this means 6x plus 7y whole square. So this left hand side is equals to 6x plus 7y whole square, and now we will plug x and y values. So 6x means 6 times 3 plus 7y means 7 times 6. So this whole square, then we will solve for it. So 6 3 is 18, and 6 times 7, what it equals to? It equals to 48, not 48, sorry, 42. Now just add them, so it will be 10 4 5 and 6, and the final answer will be 60 times 60, which is equals to 3600. So my final answer for the first is 3600. Okay, I hope you understood it very well. So let's jump into the answer. So yes, indeed it is 3600. Okay, now I am leaving you the second part. Okay, so this part is your answer, sorry, for homework. And please let me give you some hints. So hint for this is, hints are, if you try to see, 25 is equals to 5 square, 16 is equals to what, 4 square, and 40 I can rewrite it as what, 4 times 5 times 4, which is 20, and then 2. So you can see now, you can make some relations in as we did in the first part. Okay, so I hope that you can easily do it. Okay, so let's move, and here your answer will be a 4. So I'm just jumping it to the next question. Now in this question, or in this example, if x square plus 1 by x is equals to 23, then what is the value for this? So just use the identity, or just use the concept. So what concept I am talking about? It is quite easy. So if you recall that a square plus this is the same thing as this. So b square minus what, sorry, it is equals to what? So x plus 1 by x whole square, if you remember, is equals to minus 2. Okay, so this is, and we need, so this holds and we need this value, and we are given that this left hand side is equals to 23, and the other terms remains untouched. Then I put this minus 2 over left hand side, so this becomes plus 2, and this whole left hand side becomes 25. So if you see that whenever we remove power from one side, then it will get another side and becomes that root. So this means it will become square root. If for example, if a cube is given to me, say 8, then on other side it will become 1 upon 3, or we say cube root of 8. Okay, I hope this is clear. For in this case, the a square, if given to me 4, then a square will get to square root of 4. Okay, I hope this is clear, and we know the square root of 25 is just 5. So the value for x plus 1 by x is just 5. I hope this is clear to you. Okay, it is actually the plus minus 5, because if this value is equals to 5, then my answer will be 25. Yes, if its value is minus 5, then the output will also remains the same, the 25. So the actual answer for it is equals to plus or minus of 5. Okay, so two answer for that. Let's move on next. Now what? Now in this question we have to prove that a square plus b square plus c square minus ab minus bc minus ca is equals to half of a minus b whole square plus b minus c whole square plus c minus a whole square. So just take the left hand side. So taking left hand side, then using the formula for if you recall, the a minus b whole square, which is equals to what? A square plus b square minus 2ab. I hope you get this formula, and we will be using this formula again and again for this term, for this term, and for this term, and then just simplifying will get me the left hand side. So let's begin with right hand side. So my right hand side is half times 2a square becomes half times 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ac. Why? If you see that this a minus b whole square is equals to a square plus b square minus 2ab, and b minus c whole square is equals to b square plus c square minus 2bc, and this c minus a whole square will give me c square plus a square minus 2ac. So by putting these value in place of this, okay, you will get your term like these. Okay, I hope you are seeing. Okay, so I think this solution given me is the taking left hand side as the center, but I am solving it here taking the right hand side. Okay, so let's solve with me. So just put all of these value in places of their values. So let's see what will happen. So now my left hand side, the right hand side is this b minus c and c minus a. I hope this is clear, the right hand side. Now just putting these respective identities, I will get what I will be getting. I will be getting this a square plus b square minus 2ac ab plus b square plus c square minus 2bc plus c square plus a square minus 2ac. If you see, I have 2a squares, 2b squares and 2c squares. So this means I will be getting 2a square plus 2b square plus 2c square, and other terms remains untouched. So minus 2ab minus 2bc minus 2ac. If you see, I can take 2 common out of each term. So 2 common out from here, 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 here and here, and by taking common, this will happen, the 2 get cancelled. Inside of the bracket the terms remains are just a square plus b square plus c square minus ab minus bc and minus ac. So this was our left hand side. So we proved or we started from right hand side and got to left hand side. So this means we proved our question. So I hope the proof is clear. But if you see the solution here, so in solution we started with taking left hand side and took a left hand side and just put the respective value or do some manipulation. So what manipulation we did, just multiply and divide by 2 inside, and then we will get 2a square plus 2b square plus 2c square minus 2ab. So this is just minus sign. So minus 2bc minus 2ac, and we know if you make pairs, so what pairs I am talking about, this pair and pair for, if you first of all this 2a square can be break it down into 2 parts, or just a square plus a square, do the similar thing to b square plus b square, and 2c square can be separated as c square plus c square. So using this a square and this b square and this minus 2ab, I know this makes one pair. Then use another a square, another the c square, and this minus 2ac makes this pair. In the similar manner, this pair will be there. So now I know this is the identity for a minus b whole square, this is for b minus c whole square, and this is for c minus a whole square. So we started from left hand side, we got to right hand side. So I hope both of the approaches are clear to you. Now let's move and solve for next. In next question, we have to evaluate the 107 or the 107 square. Just use, don't do the manual multiplication, which is this. It is lengthy. Just use formula we used. So how I'm going to use the formula is just quite simple. So 100 plus 7, I can write 107. So 107 is equals to 100 plus 7. Yes, yes. And I know 107 whole square is equals to 100 plus 7 whole square. This means this 100 is my A plus 7 is my B, and the what identity I will be using? I will be using A plus B whole square, which is A square plus B square plus 2AB. And I know A is my 100. A is my 100. So 100 square plus B. B is my 7. So 7 square plus 2 times A. A is my 100 times B. B is my 7. So this 100 will become 10,000. This 7 square becomes 49. And this last term become what it will become? It will become 1400. I hope this is now clear. Now just we have to add. Okay, so adding this, the 0, the 9, the 0 will give me the 9 unit, the 9 number as my unit. And the 10th place I will have the 4, and on the 100th place what I will have, let's see, the 4, just 4. Yes, and the 1000 place, at 1000 place I will be having 1, and the this, then my digit will be, or my answer for this square 107 will be 11449. Okay, 11449. I hope this is clear. Okay, so let's move to next and see more. So just solve it like the previous. So now we see 100 minus 6 is equals to 94, and 100 minus 6 whole square, which will be equals to 94 square, 94 square. And indeed this is our question. So solving for this is the same as solving for this. Now apply the formula A minus B whole square here, and you will get your answer. So you will do it by yourself to see that if you remembers the formula or not. Okay, so I am not doing it, and also I am not giving you the answer. So please do it by yourself. It is for your homework. Let's move to next. Okay, so how now, what is our approach for this type of question? It is quite simple. So I know the point 99, I can write it down as like this, and for square of this will be equals to square of this. So, and in this case, if you see, I know if A by B whole square is equals to A square by B square, I know this. So this is a 99 square, or just not separate it yet, just do it like this. 99 I can write it as 100 minus 1 by 100 whole square, which is further equals to 100 by 100 minus 1 by 100 whole square. And now I know this will be 1. So 1 minus 1 by 100 whole square. Now use the identity. Now use A minus B whole square to get your answer. I hope you understood how I did, or how I get to this point. Okay, let's move to C. So 1 minus 0.01 or 0.01 is just nothing but 1 by 100. Okay, this is another form, but the same as the previous form. So just use a minus b whole square. So what it is equals to, just repeat behind me. It is a square b square 2ab. And now what are the symbols? If you recall, here what we use the plus sign, and for here we use minus sign. I hope this you remember. Okay, so this is my formula, so use just this. So a is my 1, and this is my v. So 1 square plus b or 0.01 square minus 2ab. So 2a and b. So 1 square is just 1. Okay, 1 square is just 1. 0.01 square is, or 0.01 whole square is equals to this, and we know this is 1 square upon 100 square, and 100 square and 1 square is 100 square is 10,000, and this is in decimal. I know 0.0001. So yes, this is written over here, and minus 2 multiply with 1 times 0.1, this is equals to 0. This last term is equals to 0.2 just, and minus is already there. So 1 plus, so so this will give me 1.0001, and subtract it 0.2. Okay, you will get your final answer. I hope you understood it. Okay, let's move next and see more example or note. Just so in our note, if you try to see that we may extend the formula for squaring a binomial. So what do we mean by binomial? Binomial means a polynomial having just 2 terms. So to squaring of a trinomial as given below. And trinomial, what we have, a polynomial with 3 terms. So in this the essence for this note is we extend the formula for squaring a binomial. This means, this whole terms means that we know a plus b whole square is equals to a square plus b square plus 2ab. Then we can make use of this identity to find out the value of a plus b plus c whole square. Okay, so how we are going to do that? So it is quite easy. Just use brackets. So a plus b plus c whole square is the same as a plus bracket b plus c whole square. Now this is my just capital A, and this whole term is my capital B. So using in this formula, a plus b whole square is equals to a square plus b square plus 2ab. So I am just using capital A equals to small a, and capital B is equals to b plus c. So using in this, what I will be get small a square. And now I know b is my b plus c, and capital A is a just. So a small a square plus b plus c whole square. So b plus c whole square plus 2 times a times b plus c. So 2 times a times b plus c. So now just it remains the same. B plus c whole square, I can further evaluate it. So b square plus c square 2bc, and plus 2 times a. I multiply this 2 times a first to b, and then I multiply this term to c. So it will get me what first of all there is some error, so it will be 2a here. Then I will use the distribution property. So how I am going to use it, just see. So these all things remain untouched, this also remains untouched. So now just multiply it by b. So 2ab we get 2ab, then multiply by c. So 2ac we get 2ac using distributive law. So what distributive law we are talking about? We are talking about the distributive law of this. If this is our case, then this a multiply with b first, so ab, then this a multiply with c first, ac, then we use plus symbol here because of this. Okay, so ab plus ac, so we use just this. Okay, so now these all are remain same. Okay, so we extended our squaring a binomial to squaring a trinomial. So we have another identity, a plus b plus c whole square, which is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Okay, I hope you understood all very well. So we will continue our topic and see more exercise later. We see more exercise. So for today, thank you, and that's for this session. So thank you for having with me. Thank you.